Welcome to Snark Chocolate, a show about ZK products where we break them down with rich flavors and sweet insights. I'm Omer and I'll be the host for this episode. Today we're thrilled to be joined by Alan Szepieniec, co-founder of Neptune Cash, a Layer 1 peer-to-peer anonymous cash protocol featuring privacy, scalability, and post-quantum security. Alan, it's great to have you on the show.
It's great to be here. Thanks for having me.
Can you share with us a bit more about your background and what got you one day to wake up and choose to build a new blockchain?
That's a bit of a loaded question because I don't think there's any one morning where I woke up like that. Perhaps the best way to answer this question is to say that I have two backgrounds. One is in cryptography. I did my PhD in post-quantum cryptography. And after that, I continued doing research, not at the university, but for various blockchain companies. And the other background is libertarianism. I was converted by Ron Paul in his 2008 campaign. I bought his book, The Revolution, and it's not really a campaigning leaflet. It was a introduction to libertarian way of thinking. And all the way at the end of that book, there was a reading list. And so after reading that book, I continued with the reading list. And so I discovered Murray Rothbard and lots of other writers, but Murray Rothbard in particular is What Has Government Done to Our Money very much struck a chord. And that's how I started thinking about money. This was 2008-ish. A few years later, I hear about this thing called Bitcoin. I dismiss it out of hand, of course, because it's not gold. And it took a while for me to realize that the world is evolving and gold might not be the best money anymore. And so is Bitcoin the best possible money? It has a good claim to that title, but there are technical deficiencies that we're hoping to address with Neptune.
So you recently launched the chain. Congrats. Second, before diving in and learning more about your experience, to unpack what Neptune is. And I guess the first question I have is, what are the unique features for Neptune Cash compared to others?
So the slogan is post-quantum security, scalability, and privacy. But maybe that's not too informative to the audience of this podcast, which I expect to be technical and ask questions. How do you achieve this privacy? How do you achieve this scalability? And so maybe the right way to present it is ZK Starks at layer 1. There is a VM, ZK Stark VM, and we use it for scalability. So you produce your proof on the side of the client, and the blockchain only ever sees a proof, so that when it is being verified, you don't need to re-execute a smart contract or a transaction. Just verify the proof succinctly. You get privacy, not for free, but zero knowledge comes for free if you use a proof system. And post-quantum security does come for free, and that's actually the least interesting part because post-quantum signature schemes already exist, and it's very little effort to take Bitcoin or Ethereum and replace the quantumly insecure signature scheme with a quantumly secure signature scheme, and boom, you produced a post-quantum blockchain. The reason why it's uninteresting is because we don't use signature schemes to begin with. We only use proofs. Proof of ownership of the funds that are being spent in a transaction. In the end, every transaction comes with one proof that establishes the ownership of all the funds that went in, that establishes none of the funds are being double spent, that establishes, since the funds are hidden behind commitments, establishes that no inflation is taking place, that the outputs are positive, and so on. And it naturally gives rise to things like transaction aggregation, where you can merge two transactions just by concatenating their inputs, concatenating their outputs, and replacing the two proofs by a new proof, recursive proof of validity of the original proofs.
What inspiration did you take from existing chains?
Well, there's an obvious debt to Bitcoin and Ethereum. Bitcoin for proof of work based consensus and the idea that you can build your own money as a hacker endowed with programming skills. Ethereum for smart contracts. And then besides Bitcoin and Ethereum, I'd say we're using the lock script and TypeScript distinction that Nervos markets came up with. So the lock script determines who can spend funds, and the TypeScript determines how the state evolves. And so if you're only thinking about money, then the TypeScript is very simple. It's just saying there can be no inflation. But if you're spending user-defined tokens that expire or can be traded contingent upon certain events, then the TypeScript has to encode that logic. What else? There's a lot of technical and scientific debt to researchers and programmers in the field of zero knowledge, and I guess we have debt to Zero Cash, Zcoin, Monero, and so on, because we're also using zero knowledge proofs to achieve privacy. Yeah, that's off the top of my head.
So maybe one step back, can you give us a high-level idea on the design of Neptune Cash? I mean, proof of work, proof of stake, and so on, consensus.
Right. The consensus mechanism is proof of work. We think there are deficiencies in proof of stake that we can get to later. But for now, the proof of work, it's not just sampling a nonce, hashing the block, and checking if you are below a threshold, because that mechanism does not account for the workload of producing proofs. Every block in Neptune Cash contains a proof of correctness. In the future, this proof of correctness will also cover the correctness of the previous block, but right now we don't have that yet. But what we do have is every block contains one proof and one transaction. And that transaction is the merger of potentially a large number of atomic transactions. And so the question is how to reward the persons who produce that proof, because producing proofs is a work-intensive process. And so the solution we came up with is two-stage mining. So there is a block subsidy. Right now it's 128 coins per block, and in 3 years, or 2.5 years rather, it will have, and then it will only be 64. And in the first stage of two-stage mining, you have a composer who composes the block. He samples transactions that were broadcasted on the internet, broadcasted on the network rather, and he merges them into one big transaction. He produces the block proof for the block that contains that one big transaction, and then he broadcasts a block proposal. In the second stage, guessers listen for block proposals and they start guessing, which consists of sampling the nonce in the header and checking to see that the hash of the block is smaller than a target threshold. So the idea is that the block subsidy is split between the composer and the guesser at a rate determined unilaterally by the composer. So if you are in possession of fast hardware, clever optimizations, and so on, then you can compose really fast and charge a high fee for that fast composition. But after a short while, competing composers who are slower and maybe more cost efficient, they will come up with block proposals that outbid yours. And then all the guessers will switch to the new block proposal. And over time, the guesser portion of the block reward increases and the composer proportion of the block reward decreases. The fact remains that guessing is embarrassingly parallelizable. And so that's where we derive the difficulty to revise the chain from. And composing is not embarrassingly parallelizable. And in the limit, it will account for a small fraction of the mining rewards.
So one question I'm curious about is, I guess it has two parts, right? So one is like ZK, right? You have this very big component of ZK, and you know, as a result, also you specify some hash function and like other things that can change over time. I mean, what is how do you cope with that? What's the mechanism to upgrade or to make changes with technology that's moving fast, like ZK?
It is moving incredibly fast. That's true. We are concerned with writing code first, and as a strictly subordinate priority, the first, keeping track of where the science is headed. And so we don't have the most cutting edge techniques, but we do have a fully functional recursive Stark engine. What would we need to see in order to integrate changes? It would have to be either a cryptographic vulnerability. With a cryptographic vulnerability, all bets are off, and we will update as quickly as possible. If it's a dramatic performance improvement, like 2x or more, then we'll probably implement it. But I have to put that probably in that sentence because there are other things vying for our attention. And so maybe 2x is not enough. But if it's 4x, then it's definitely worth it.
Is it up to you? Is it up to you to update? I mean, you don't need some kind of like fork rule to get an update to certain parts?
Yeah, any updates to the Stark engine would require a hard fork. And that's why we prefer to keep very few and far between. That said, we probably are going to integrate STIR, the low degree test, and it also allows accumulation schemes. We're probably going to upgrade Triton VM with those techniques. And so there's at least one hard fork for this purpose in the works.
I guess it's like a gift that keeps on giving, because like ZK would keep improving, let's assume, and you can just keep pushing updates. The technology matures.
As the community grows, it will become more and more difficult to deploy hard forks unless you stay centralized. But we don't plan to stay centralized. We plan to disappear when the time is right and pass the torch on to a community of maintainers who now maybe they don't exist yet, but when they do and the time is right, then the founders will not be engulfed anymore.
And that's an interesting choice. How do you envision like this process would look like? I mean, because you're like the Vitalik of Neptune, right? In a sense, he's still around, and you want. So what's the model here? Like, because there's also the risk that I mean, I can just copy your code and update like the ZK stuff, assuming it's not gonna break due to security or whatever. And you need some kind of like, I guess, like weight of like community leaders.
You can copy the code, but you cannot copy the community. And I guess we're hoping that the community is using the code as a focal point rather than individuals as a focal point, because money is too important of a project to put in the control of any one or any two individuals. And we don't want that kind of responsibility.
From what I recall, there are like certain parameters when designing a blockchain. I guess just like, maybe it's a stupid question, but how do you pick these parameters? I mean, are there any magic numbers that you just pick and then optimize as time goes by?
So there's the security level, which we set to 160 bits. And you might say that's overkill. Nobody needs more than 110. If you're looking to secure against the far future, 128 should be more than enough. 160 is definitely overkill. And the reason why we went for this number is we did a back of the envelope calculation, assuming that we could surround the sun with computing devices that are as efficient as computing devices that we have today. And then it would take around 1 million years at current energy consumption rates of computing hardware to find a collision to a black box hash function with 160 bits of security and 320 bits of output. And so that's a nice what is it? It's a perspective on the solar system scale significance of blockchain money, but after you start expanding into different solar systems, blockchain money starts becoming a little silly because of relativistic effects, and you cannot synchronize on the chain anymore. And so you really don't need more than one sun.
Okay. Touching on a different topic. So as we mentioned, you recently launched the chain, and maybe you can share a bit on your experience so far. How's it look?
So the launch date was certainly delayed several times, and I guess that's the result of the universal rule about planning. First 80% of the work takes 80% of the time, and the second 80% of the work takes another 80% of the time. The third 80% of the work takes. It goes on like that. So it was delayed, and then when we finally decided, okay, we're going to announce now that the 11th of February is the launch date. We still wanted to run an internal audit, and that took a few hours longer. So in the end, we had announced to launch the Genesis block at 12 o'clock, and we only got there at 10 o'clock, some 10 hours later. So that's one thing, difficulty of planning. We had made a rather embarrassing mistake whereby the network parameter, which network you're on, it was still set to testnet in version 1 of the software. And so when it has to do with the TARPC command line, no, not TARPC, the CLAP, command line argument processor, not recognizing the default network that's put on the enum. Anyhow, if you download the version 1 of the software and connect without special command line arguments, you will connect to the wrong network. And so we had to hurry up and release a second version that fixes it. Early on in the Telegram channel, people had figured it out, and they had already announced this is the command line argument that you need to connect to the correct network. And there were unforeseeable network connectivity issues, firewalls, NATs, and so on. That's really, really difficult to prepare ahead of time for. And in the end, there was a period shortly after launch where we, the two founders, were actually isolated from the network. We had two running nodes that were connected to each other and nobody else. And we saw on the Telegram channel that others were connected to a larger network. And that had to do probably with firewalls and NATs, but we're still not sure. And so in the end, we solved that by purchasing or renting a cloud server that opens up all ports and accepts connections and allows outgoing connections, and it's a hub to the network because it's connected to everyone, possibly to everyone, and it's not the ideal network topology, but at least it ensures that everybody is connected to the network. And so over time we'll probably rewind that, but first we need to put a decent deal of attention to fix all these networking issues, of which we are not experts.
So we are in the very, very early days. And do you see any traction, any kind of like good surprises, bad surprises, community being built around the protocol? I mean, right now it's like, fully decentralized. Am I right?
It's quite decentralized. So around 4 weeks after launch, we were notified by safetrade.com that we had been listed, or rather Neptune Cash had been listed. I guess I shouldn't say we if I plan to pass the torch on later on. Neptune Cash was listed without any involvement from the team. That was surprising and welcome. So we've had a market price basically since March, sometime in March 2025. There were or have been three mining pools. So that's another indication of community building, community growth. There's a community built wallet. Yeah, so there are a couple of projects that are initiated by the community, but it's fair to say that the overwhelming majority of commits and PRs to the code base are still coming from the team. So I guess that's not really surprising because we are the only ones with commit access. But even if you look at PRs, there are a handful of PRs that are submitted by community members, but most of them are coming from the team. And so the things that the community is working on are separate repositories, and we're eager to support them and I don't know, activate or implement RPC endpoints that they would need. But this might be an area where we can improve communication with the community, because one project needs the endpoint to do this, and the other project needs a slightly different endpoint, and then how do you decide what to do? It's a discovery process.
Okay, so talking about developers, what do you expect? Or let's ask it differently. What are the ways developers can interact with the protocol today?
So the source code is open source. It's on GitHub. You check it out, and you can compile it and run it, and you can tweak it. And once you start tweaking it, then you enable, or rather, you would need to tweak it in order to enable smart contracts that you want to write. And if you want to write a smart contract, what you need to do is you need to write it in TASM, which is the assembly language for Triton VM, which is our start engine. Yeah, right now the client only recognizes two smart contracts. One is the native currency, and two is the time lock smart contract. And so if you want to develop a smart contract, then you write it in TASM and you make the client aware that this other smart contract also exists. The protocol makes abstraction of smart contracts, so it wouldn't need a hard fork or a soft fork or any fork whatsoever, but you would only be able to use this smart contract with other participants who have same software, same tweaked software that you have. So I guess the tooling for smart contract developers is limited. There is a compiler from a subset of Rust to TASM, but there's no integration into the client yet. That's on the roadmap, but right now we have different things to focus on.
Okay, so let's jump to the future. Let's say that someone listens to this episode a few months from now, maybe a year or two. What kind of use cases you imagine will be built? What smart contracts that do not exist today would exist and people would use them?
Well, anything DeFi, but with privacy. And its privacy is nice in some cases, and it's a civil rights thing in other cases. But in some financial cases, it's a necessity. You cannot afford to expose your portfolio to your competitors. And in the simplest possible case, that's what we see with miner extractable value. And it's because the trades are being broadcasted, and the miner has the opportunity to rearrange them so as to benefit themselves. I guess censoring is difficult, but still kind of possible. the point is MEV is possible because all these trades, all these transactions are transparent. And once you have privacy, then they're not transparent anymore. There are other use cases besides DeFi plus privacy. There are things that you cannot do on just a smart contract platform, like bounties for mathematical theorems. Like here is a lump of money that will go to whoever produces a machine verifiable proof of the Riemann hypothesis. If you try to do that on a transparent smart contract platform, whoever produces that proof will end up being front run by a miner who collects their bounty. But if it's a zero knowledge proof, then the miner doesn't know what the transaction is achieving. They won't be able to reproduce that transaction, and so they won't be able to steal the bounty. This is perhaps more of a selling point for the UTXO model than for privacy, but we think there is room for Lightning on DeFi. And the reason why I say UTXO thing is because Lightning just works better for UTXOs than it does for accounts. So if you have Lightning and DeFi, then you get high frequency trading on the blockchain trustlessly. Yeah, those are a few applications off the top of my head, but it's worth remembering that the biggest application, the most important application, is of course money. And everything else is subordinate to that number one application.
Yeah, hearing you now talking about this form of private smart money is like make me realize how much like such a huge undertaking what you guys are trying here to accomplish. And there are a few ways or a few directions we can take it from here. One small question I had was specifically about ZK. So it is compute heavy, and given that you want some privacy, you need to find a way to manage that, right? Either outsourcing or like manage somehow like efficient way to run ZK on device. Have you thought about that? Like what?
We have. So the solution we came up with was where you can broadcast two types of transactions, and the transaction kernel is identical. The thing that's different is which kind of proof supports that transaction kernel. In the one case, you have a single proof, and that's what the blockchain understands, or rather, the single proof is the thing you merge together with other transactions, and the thing that goes into a block once you're done merging. That's on the one hand. On the other hand, you have a proof collection. It's called because it's multiple proofs, multiple start proofs, in fact. And you can broadcast a proof collection without degrading privacy, without without leaking spending keys. And the point is that it's a lot cheaper to produce those proofs in the proof collection than it is to produce the single proof. And so you can conceivably produce the proof collection on device, send it to the network with a fee that can be gobbled up by someone who upgrades the proof collection into a single proof. And they would need a bigger machine to do that, but they're collecting a fee for it, and so there's an opportunity for supply to meet demand in that market.
One somewhat technical question, but doing the research for this episode, people pointed it to me. What are mutator sets, and how are they being used?
Mutator sets are a cryptographically authenticated database, and they share that name or that title in common with Merkle trees, accumulators, and so on. They are simultaneously accumulators and mix nets. And so you can put items into the mutator set, you can take them out, you cannot take them out twice, and the operation where you insert it is unlinkable to the operation where you take it out. And so we are using the mutator set as a succinct representation of the UTXO set. The items that are being put in are UTXOs confirmed by transactions, and the items that are taken out are UTXOs that are being spent by transactions. The keyword is succinct. So in the end, the representation of the mutator set is 300 kilobytes and is unlikely to grow much further beyond that, independently of how many items there were historically or are currently in the mutator set. And the cost of proving is also, I guess, dependent, but logarithmically dependent, so practically independent of the size of history and number of items in the mutator set. There are drawbacks to this architecture for anonymity, though, which is that you need to maintain membership proofs in the mutator set of UTXOs that you own. And so basically that means that you either stay online, and with every block, there's a little update that you might need to do to your membership proofs. Or if you go offline, then when you come online, you have some catch-up work to do. That's the biggest drawback. Another drawback is that we don't get as much anonymity as, for instance, Zcash or the full chain membership proof that Monero is moving towards, where you basically treat every historical UTXO as a potential origin. In our case, in the case of mutator sets, the anonymity set is on average 32 with a minimum of 8, and it's more or less, it's you have a fuzzy timestamp, so it's more or less the UTXOs that were confirmed at roughly the same time that constitutes your anonymity set.
Thanks. Before we wrap things, I wanted to also get your take more broadly on like the ZK landscape. Maybe you can share your views. How do you see it evolve?
I'm surprised every day and excited by the pace of research. If you had, I thought we'd reached a peak long ago, and I keep being surprised by how much mountain there is left. That's in terms of research. I wish I could keep up, but I really can't. I'm not sure anybody can unless you have a professorship position and several underlings working for you to summarize papers that you obviously don't have time to read yourself. Maybe in that capacity, someone can do it. That's in terms of research. In terms of practice, I think we feel vindicated by Ethereum's pivot towards a proof-centric architecture. To us, that was obvious 4 years ago, but it's good to know that smart people agree. Let's see. We're a little surprised, though, that all the zero-knowledge VMs, pretty much all the zero-knowledge VMs out there, with a few exceptions, that they are targeting Ethereum. And I would have expected more diversity there. In terms of performance, I am very skeptical about basically everything, every single benchmark out there. I tend to think they are contrived to benefit the VM that is in need of a headline. And the benchmarks are rarely looking at practical tasks that you really need to do in practice. Which includes recursion, obviously, but recursion is rarely part of the benchmark. What else is there to say? I think there's, I guess I'm a little dismayed by how much of zero knowledge research and practice is not about zero knowledge, but about scalability. I mean, scalability is a fantastic benefit too, yes, but I think privacy is just as important, if not more important. And I would like to see more attention given there. And I would also like the markets to agree with my subjective preference that privacy is important too. And right now, obviously, the market disagrees. If you look at the market caps of ZK VM projects versus privacy projects.
Oh, well said. Thanks for sharing. So yeah, I mean, the final question we ask all of our guests is to name one project or product that you are bullish about.
Night and VM. And the reason why I'm bullish about it is because they have a very similar architecture, client-side proving, stark VM, smart people going for them as well. But I'm probably also saying that because I'm very familiar with the folks there, and they know what they're doing, and I can tell.
Yeah, good choice. Okay, so Alan, thank you so much for joining us today.
Thanks for having me.
I enjoyed it a lot. I actually learned a lot listening to you. Hopefully our listeners will also enjoy it. And for those interested to learn more, we've added some links in the show notes. So thank you again, Alan.
Thank you.